A glacier is a big chunk of ice that is persistent, so it sticks around for a long period of time, rather than forming and then melting back into water within just a few years or less. It moves under its own weight, so it's not holding still. It's hanging out, getting big, and then eventually slowly shifting geographically because of how heavy all that ice it has accumulated has become. Glaciers are also distinct from sea and lake ice, which are sort of like glacier ice, but based on water rather than on land. Ice that forms on water tends to have more size and shape and weight variability because of the nature of the water upon which it floats, and because it's more likely to move around a bit because it's floating rather than holding still on relatively more stable land. 99% of glacial ice on Earth is located in what are sometimes called continental glaciers, and sometimes referred to as ice sheets. These ice sheets are primarily based at the planet's poles because of how the globe is tilted, and thus where heat tends to aggregate, on average, more toward the equator, with less sunlight-delivered heat and fewer climactic systems moving and storing heat within the Arctic and Antarctic regions. But glaciers are also found elsewhere, especially in higher latitudes, because, again, these are regions that tend to be colder, and when it's consistently cold, these bodies of ice have the chance to form and then stick around long enough to accumulate more and more ice, eventually becoming so big that their heft causes them to start moving. Glacial ice holds somewhere in the neighborhood of 69% of the planet's fresh water, and that's important for many reasons. But most immediately, because runoff from these glaciers, water from portions of them that melts and then reforms year after year, serve as a fresh water source for around 22% of the planet's human population. That's about 1.9 billion people who rely on direct glacial water runoff as their primary water source. And that's alongside just a silly amount of other organisms, a practically unquantifiable number of them, as creatures from the microscopic on up live under, in, and upon glaciers. And entire ecosystems in the surrounding area are dependent on the fresh water they store, release, and moderate. Just as the larger global water cycle moderates how much water is in any given place through processes like evaporation and rainfall, glaciers participate in and mimic aspects of that system by collecting and freezing water, storing it, but then also going through a regular freezing and partial melting cycle that ecosystems and humans have come to rely upon. They are why some areas aren't perpetually flooded, and why others aren't perpetually starved of water. And they store, among other things, carbon and methane, much of which is soaked up or generated by microorganisms that live within or under the glaciers, and most of which is then tucked away in pockets under or within the ice. These freeze-melt cycles also power many rivers and streams, which in turn enable water-based travel and hydropower. Cold water runoff closer to the glacial source also helps regulate temperatures by essentially pulling in heat and moving it further downstream. And many cold weather traditions and activities like skiing and snowboarding and mountain climbing and ice fishing are in part enabled by glaciers, as they hold the cold at higher altitudes and thus create the foundation for snow and the crisp, chilly temperatures in such regions. Glaciers have also, though, long served as a kind of canary in the coal mine for climate scientists, as they've been in a fairly consistent retreat since 1850. A year that's been identified as a bit of a pivot point for humanity, as there was a marked increase in the quantity of measurable greenhouse gases being released into the atmosphere, alongside a relatively small collection of adjustments to global weather systems and the aforementioned early glacial decline, which glaciologists have tracked and developed models for, models that now suggest 1850 was the end of what's often called the Little Ice Age, which began maybe as early as the 13th century, but possibly was more recent, beginning in maybe the 16th century. In either case, this little ice age ended in 1850 with a hockey stick graph increase in global average temperatures, and the same in average glacial melt and decline, a trend that seemed like it might be going away momentarily during the few decades ranging from about 1950 until 1980, but which then flipped back around with a vengeance headed into the 1990s and beyond. What I'd like to talk about today is one glacier in particular, sometimes called the Doomsday Glacier, and how we share information about and respond to big, psychologically weighty issues like those related to climate change. You're listening to Let's Know Things. I'm Colin Wright. Let's Know Things is an independent, listener-supported show. If you're enjoying what I'm doing here, consider becoming a supporter. One of the simplest ways to do that is to become a patron at patreon.com/letsknowthings. You can also become a member at understandery.com. But you can find an array of options, both monetary and non-monetary, at letsknowthings.com/support. A great big thanks to everybody who's already helping to support this show, and thank you in advance if you're considering doing so in the future. All right, let's get back to the show. This is maybe at the forefront of my mind because we're coming to the end of another year, 2021, that, for many of us at least, has been defined by an immense amount of uncertainty. A global, deadly pandemic, devastating weather events on historic scales, corruption, and the creep of authoritarianism throughout the ranks of global leadership, and a constant drumbeat of news items about novel technologies few of us understand, at least in a practical way. Repeated upendings of financial systems, dramatic changes to governmental bodies and alliances and agreements, and the near-constant specter of military conflict, of hacking, of previously reliable societal norms and knowns becoming fragile and, perceptually at least, vulnerable. There's a lot going on pretty much all the time, and while this could arguably have been claimed at essentially any point in history, we're more aware of it now, and that influences both our perception of the world and our levels of stress and anxiety and our capacity to act upon the information to which we're exposed. It's because of this torrential tangle of tumult that when headlines like the one I'd like to start with today pop up, I don't necessarily know what to do with the information. It sounds generally bad, and if we allow ourselves a moment to chew on what the words seem to mean, we may even come to think of it as being really, really bad. But what do we do with really bad information about a subject over which most of us don't have any actual control? That in mind, the article I'd like to start with today comes from Axios, and it's entitled, "Cracks Could Cause Key Ice Shelf Holding Back Doomsday Glacier to Collapse." The Doomsday Glacier, mentioned in that headline, is actually called the Thwaites Glacier, and it's located in Antarctica, travels about 1.2 miles, which is about 2 kilometers per year, at the so-called grounding line, where the ground-based portion of the glacier gives way to the water-based floating ice shelf, and I'll come back to that concept in a few minutes, and it gets its official name from a glacial geologist named Frederick Thwaites, but its nickname, Doomsday Glacier, comes from its absolutely boggling size, about 80 miles wide, which is just shy of 129 kilometers wide, and between 2,600 and 3,900 feet, which is about 792 and 1,189 meters deep, at the aforementioned grounding line. That, and its potential, should it ever break off into the ocean, the portion that's currently on land, sliding into the water, to raise global sea levels by a significant amount. Current estimates suggest nearly 3 feet, or about 0.9 meters, in fact, which, for comparison, Sea levels have risen about 8 or 9 inches since 1880. That's about 21 to 24 centimeters. And 3.6 inches, or about 91 and a third millimeters, of that 8 or 9 inches happened between 1993 and 2020. So this is a process that's been speeding up, and we've already lost a good deal of land, and some entire low-lying island nations are on the brink of being perpetually flooded, all of their inhabitants having to move elsewhere, with just that existing handful of inches of sea level rise. Important to note here is that this is the overall level, not taking into account flooding, which increases during certain seasons and after rainfall and storms. So while a matter of inches might not seem like much, it's a big part of why some cities are now seeing dramatic flooding on a regular basis. Whereas previously, they might have had floods worth noticing maybe once in a decade, or even less than that. The average consistent water level is rising, so it takes less of a temporary increase to send floodwaters into previously unflooded or seldom flooded land. This is a big deal because in addition to those low-lying island nations that are already seeing the effects of this, 8 out of 10 of the world's largest, most populous cities are near enough to coastlines to be affected by sea level rise, and almost 40% of the US's population, 60% of China's, and more than 40% of India's are in highly at-risk areas, with the population in such cities growing every year in all of these countries, and in many other countries around the world as well that face similar problems. Lacking significant infrastructural investments, like the building of seawalls and dikes, and other systems to help prevent flooding and remove water that slowly or quickly overwhelms these inhabited areas. Some of the world's largest cities could be underwater most or all of the time by the year 2100, even with existing slow growth sea level increases. And between now and then, we are likely to see large exoduses of people out of these areas and waves of lost assets and lives along the way. So that's what's already happening under baked-in climate conditions. If the Doomsday Glacier were to slide into the ocean, though, things could go very sideways much faster. And this article is about a new crack along the ridge where this glacier is clinging to solid land, along the rim between its land foundation and where pieces of it melt or break off into the water, which I mentioned earlier. Satellite imagery has allowed glaciologists to keep tabs on this and other important glaciers, noting slow changes and accumulating the data sets we're now able to use to track such things and identify how these features interact with larger-scale climate systems. And the most recent assessment of this crack seems to indicate that, like damage to the windshield of a car, one significant fracture has spiderwebbed out into many fractures, and that has caused a worrying weakness across the foundations of this fairly vital, currently still land-based glacier. And that is not even the especially worrying part of this report. The truly bad news is that based on models run by these researchers on this most recent data, the fracturing of this glacier and the breakup of this ice shelf, with city-sized chunks of it plummeting into the ocean in relatively rapid succession, could occur in as little as 5 years. For context, Thwaites is already losing 50 billion tons more ice each year than it reclaims in snowfall, while also melting from below, triggered in part by warming ocean waters that have increased to above freezing in recent years, melting the glacier at ground level, both reducing the amount of ice it contains and loosening its grip on the ground upon which it's perched and to which it's clinging. Previously, frozen solid chunks of ice floe, which were floating on the water but held together by their sturdy ice composition, which surrounded this glacier, are now broken into hundreds of separate icebergs, no longer providing additional external support and stabilization to the glacial mass up on land. And there's some concern from the scientists working on the International Thwaites Glacier Collaboration, an international body of researchers dedicated to gathering enough data on this particular glacier to know what to expect and what might be done about it. There's concern from some of these researchers that if Thwaites does indeed break apart and slide into the sea, it could pull portions of other surrounding glaciers in with it, causing up to 10 feet, or around 3 meters, of sea level rise. There was already a fair bit of panic over the realization within the scientific community, a realization that emerged over the past few decades as more data was collected, that this ice shelf could collapse in this way by the year 2100, at which point it was hoped we would have new technologies and social systems that would allow us to deal with sea level rise of this magnitude in ways that we can't really do today, because it's so much more massive than anything we've seen in recorded human history. Again, remember, we've only seen sea level rise of 8 or 9 inches since the end of the 19th century. That something of this scale could happen in half a decade on the low end, and perhaps over the next few decades in the medium end, is news of a scale that, if you understand the meaning of the words you're hearing and the context in which those words are operating, it becomes difficult to process. It just impacts so many facets of everyday life that fully integrating this possibility into one's worldview is borderline impossible. I personally am clinging to the hope that this data is flawed or incomplete. This is a possibility with any data, especially about big multifaceted things like the climate or an ecosystem, which is what these glaciers are. Science is a process, not an end result, and there's a chance that in a few years we'll realize that we were missing something, and the scientists involved will correct their figures and their predictions. It's also possible that the theory underpinning the idea that glaciers plunging into the ocean causes sea level rise is itself flawed or incomplete. This hypothesis, called marine ice sheet instability, was proposed in the 1970s and has since been shown to line up well with the sea level rise that we previously had trouble explaining. It also provides a viable explanation as to how glaciers might form and disappear in a cyclical fashion that seems to line up with what we know about the history of our larger climate cycles. This theory may be inaccurate or lacking some vital bit of data or meaningful variable, and if that's the case, this posited timeline for the Doomsday Glacier might not be right, and might be entirely off base in terms of both its predicted collapse and the impact of that collapse. But it might not be, and it seems prudent, where there's a potential for global devastation on a scale and in a form that's difficult to even picture, much less quantify, that we in some way prepare for such an eventuality. And right now, from within the tornadic swirl of existing cataclysms, it's difficult to even imagine an even worse case scenario, and to imagine how on earth we're to be expected to deal with this horrible, world-changing event while we're in the midst of trying to solve several other existing world-changing events. I would argue it's important to be informed, even if we're learning about things we can't possibly influence directly, because it gives us a sense of the larger issues shaping our personal environments, and it allows us to make choices when we vote, when we consume, when we choose our jobs or how we spend our time. We can make decisions at least partially based on those macro scale variables. And if enough people do that, that can scale up. But I can also understand the sentiment held by many people who would prefer to just not have their day ruined by news that we could, in the relatively near future, see some major cities more or less wiped off the map, followed by waves of forced migration of millions of people and all that entails. I can understand why it might be more appealing to just look past such information, maybe deny it and seek out information that seems to support that denial, and to focus instead on the ultra-local, the things we can control, over which we have influence, or just to space out to focus on truly superficial things. The same applies to news about foreign wars, to suffering and carnage being wrought in far-flung portions of the planet. Again, things over which we have little or no control or influence. It can be exhausting hearing about these things, and there's unlimited frustration potential for anyone who chooses to work this kind of information into their mental model of the world and understanding of how everything fits together. It's frustrating to not know as much as we need to not be able to imagine the ramifications of such massively impactful events, and to look at our leaders and wonder why they don't seem to be taking these issues as seriously as we are, and as seriously as seems to be warranted. So while I would argue it's valuable to have at least a basic understanding of what the moving pieces are and how they fit together, I also viscerally understand the impulse to just not know, to not worry about it, to not expend my finite physical and psychological energy on things that are too big for me, and perhaps too big for our entire species, right now at least, to understand and control, and to instead step back from some of the arguably most important and vital things to ever happen to us and our global ecosystem, and to instead focus on things we feel we can actually do something about. It will be interesting to see how communication about this sort of issue, but also more broadly, evolves in the next few years to account for and possibly even directly address this sort of concept, because most of our existing channels for information dissemination don't seem to carry this type of signal with much clarity. It's tricky to distinguish hype from actual monumental information, and it's difficult to know what to do with any snippet of meaning that we might take away from such communications. I personally am going to continue to hope against hope that this particular hypothesis doesn't turn out to be supported by real-world events. But I'm also not planning on investing in any beachfront property anytime soon. And based on rapidly increasing insurance rates for beachfront property and mass sell-offs of real estate in potentially afflicted areas in many parts of the world right now, it would seem that some entities, at least, those that tend to work from raw numbers, are beginning to incorporate this potentiality into their math, shocking as the numbers might be. If you're enjoying Let's Know Things, consider becoming a supporter. Folks who monetarily support this show via Patreon at patreon.com/letsknowthings, or who become a member at understandery.com, receive an additional episode of the show each month, but also make these free weekly episodes of the show possible. But you can find a list of other both monetary and non-monetary support options at letsknowthings.com/support. The book I'd like to recommend today is called Noise, A Flaw in Human Judgment by Daniel Kahneman, Olivier Sibony, and Cass R. Sunstein. That first author is the reason I actually picked up this book. Daniel Kahneman is a well-known author. He has written several books, including Thinking Fast and Slow, but he's also quite an enthusiastic researcher. The topic of this book, though, is the data and environmental and variable-based noise that influences judgments that we make, with a particular focus on judgments that should be as free of noise as possible. Decisions made within the scope of the law, for instance, spanning all the way over into how we manage our relationships and how economists forecast where things are going next. Now, if any of that sounds interesting to you, consider picking up a copy of Noise by Daniel Kahneman, Olivier Sibony, and Cass R. Sunstein. You can find out more about me and my work at colin.io. You can find the show notes and transcript for this episode and every episode of the podcast at letsknowthings.com. You can find a bundle of my other projects, both written and podcast projects, at understandery.com. And feel free to reach out and say howdy on social media. I'm Colin Wright on Facebook, and at Colin is my name on Twitter and Instagram and most of the other ones. Thank you so very much for listening. I'm Colin Wright, and I'll talk to you again next week.